All right, this is Geometry Notes section 1.3. Looking at different angle pairs. Lots of different pairs of angles. Review what a postulate is. It's a statement that you assume to be true because it's just so darn obvious. A theorem is a statement that you can prove true using established facts. Those established facts could be other theorems you've already proven, could be postulates, could be definitions. Pairs of angles. So we have lots of different pairs here. Adjacent angles. Two angles that have the same vertex, share a common ray, and have no common interior points. Let's just draw a quick picture here. It's angle 1, angle 2, angle 1, and angle 2 are adjacent. Two angles, check, have the same vertex, check, share a common ray, check, they have no common interior points, which means they don't overlap. Adjacent angles. Complementary angles. They might have spelled this wrong. I don't know, I'm a terrible speller. There's two different types of complementary. Hopefully I didn't spell it wrong. Two angles that sum to 90 degrees. Each angle is called the complement. So for example, let's say this angle here, angle A, and let's say it's 70 degrees. Let's say this angle here is angle B, and let's say it's 20 degrees. Then angle A and angle B are complementary. They're complementary angles. We could also say that the measure of angle A plus the measure of angle B has to be 90 degrees, because when you add them, you get 90. 70 plus 20 is 90. Complement theorem. If the non-common sides of two adjacent angles forms a right angle, then the angles are complementary. So here's an angle. Here's another angle. So the non-common sides would be these ones that I'm highlighting. If they form a right angle, and that little box that I drew is a symbol for a right angle, call each of those angles 1 and 2. Angle 1 and angle 2 are complementary. Because the non-common sides, this is the common side, non-common sides form a right angle. And what does that mean if they're complementary? Once again, it means if you add their measures together, you're going to get 90 degrees. Supplementary angles. Two angles that sum to 180 degrees. Each angle is called the supplement. So let's say that we have this angle here. This angle X. Let's say we have this angle here. Picture is not drawn to scale. This is angle Y. Let's say this is 80 degrees and this is 100 degrees. We would say that angle X and angle Y are supplementary. Supplementary because if you add their measures together, you get 180 degrees. Each angle is called the supplement. So if you have angle X, its supplement is angle Y. If you start with angle Y, its supplement is angle X. Same thing with complement. Given angle A, angle B is its complement. Given angle B, angle A is its complement. It's the other angle that when you add it, you get the 90 or 180 degrees. Linear pair. Two adjacent angles whose non-common sides form opposite rays, which is a straight angle. So two adjacent angles, angle 1 and angle 2 are adjacent, whose non-common sides, this is a non-common side, this is a non-common side, forms opposite rays, a line, if you will. We would say that angle 1 and angle 2 are a linear pair. Just think of the words linear pair. It's a pair of angles that make a line. That's all that it is. The supplement theorem is based upon linear pairs. If two angles form a linear pair, then they are supplementary. So if we have these two angles, angles 1 and 2, picture clearly shows they form a linear pair because this is a line. Then the conclusion that we can draw is that angle 1 and angle 2 are supplementary. What conclusion can we draw from saying they're supplementary? We can say the measure of angle 1 plus the measure of angle 2 is 180. Next, we have vertical angles. Two non-adjacent angles formed by intersecting lines. Here's a line, here's a line. Angles 1 and 2 are adjacent. Angles 1 and 4 are adjacent. We want non-adjacent. So angle 1 and angle 3 are non-adjacent. They are vertical angles. Another pair of vertical angles, angles 2 and 4. They are non-adjacent. Which leads us to the vertical angle theorem. Vertical angles are congruent. So angle 1 and angle 3 are congruent. I'm going to mark angles 2 and 4 in a different way. You can also mark congruent angles by putting the same number of arcs and then the same number of dashes on it. Angle 2 and angle 4 are vertical angles. They are congruent as well. Identifying angle pairs. So in this picture, what are a pair of adjacent angles? Well, adjacent are angles that are next to each other that have the same vertex. So angle 1 and angle 2 are adjacent. We could say 2 and 3 are adjacent. We could say 3 and 4 are adjacent. We could say 4 and 5 are adjacent. We could say 5 and 1 are adjacent. Starting to write a little large. I wrote congruent here. I apologize. That should be an and symbol. Vertical angles. Does this picture have any vertical angles? Angle 3 and angle 5 are vertical because it's formed by two intersecting lines and they're not adjacent. That's the only pair. Angles 1 and 2 combined are vertical to 4, but we don't have a name for that, so we can't name it. Complementary angles, two angles that add up to 90. There's no indication that this picture has any angles that add up to 90. Supplementary. Well, if we had a linear pair, we would say they're supplementary. Here's a line. Angles 3 and 4 form a linear pair. Likewise, 5 and 4 form a linear pair. Cool. More questions. Different picture. Angle AFE, that's this angle here, and angle EFD, that's this angle here, are what type of angle? Well, what's 62 plus 118? Supplementary. So also they form a linear pair. So we could say linear pair. You could also say they're supplementary because every linear pair is supplementary. Angle AFE, that's the same angle, and angle BFC. Look at their measurements. 62 and 28. That adds up to 90, so these are complementary. These are not vertical angles. BFC is this angle here, and CFD is this angle here. Well, I don't know. We don't know anything about this angle. Or do we? The 62 degrees and angle CFD, those are vertical angles, so they're the same, which means this is also 62. So 28 and 62, that is going to make another pair of complementary angles. Angle AFE, that's this one again, it's a popular angle, and angle CFD, that's this one here. Those are vertical angles. You could also say they are congruent, because vertical angles are always congruent. Excuse me. So, about assuming. What are some things from this picture we can assume are true? What are some things in this picture we can assume are not true? Well, we can definitely assume that segment TW is congruent to segment WV, because they both have one dash, which then we can assume that TW equals WV. I'm just going to name some other things we can assume, but not necessarily write them down. We can assume that W is between T and V. We can assume that W is between P and Q. We can assume the angle addition postulate, PW plus WQ is PW. There's lots of things we can assume, but I want to get into specifics of things students often think when they look at this. Here's the things that we don't know if they're true or not. We don't know if this is 90 degrees. Does it appear to be 90? Sure. Pictures are not drawn to scale. We cannot assume that segment TW is perpendicular to segment WV. And I haven't told you this yet, but 90 degrees, this is a symbol for perpendicular, which means it forms a 90-degree angle. We cannot assume, even though it looks like it, that PW is equal to WQ. We do not know if that's true. Does it appear these are the same length? Sure. Picture doesn't show it, so we cannot assume it. Let's look at a real example. Angle dog and angle got are complementary angles. Let's see if we can draw this. What's the vertex of these angles going to be? It's the letter in the middle. It's going to be O. Now, what letter do they have in common? Dog and got. They have the G in common. So G is going to be on the interior. D and T are going to be on separate rays. There we go. Now it says these are complementary, so that forms 90 degrees. Measure of angle dog was 2x plus 18. Measure of angle got, 7x plus 9. Find the measure of angle dog. Before you try to find the measure of angle dog, you need to make an equation. We drew this picture first. Now, using the angle addition postulate, we could say measure of angle dog plus measure of angle got equals the measure of angle dot. Now, you could write this and it's fine. You could use that's using the angle addition postulate, or you could say I want to use the definition of complementary angles, which says if you add the measures of these angles, you get 90 degrees. Those are both acceptable, provided you give the proper reason that you were able to do that. Using substitution, this is our second step. Measure of angle dog is 2x plus 18. Measure of angle got is 7x plus 9er. That's trucker talk for 9. We combine like terms. 2x and 7x is 9x. 18 and 9 is 27. Let me give you a pro tip right now. To finish this problem, you have lots of choices, and I don't care what choice you choose, as long as you're choosing a choice that's choosable. It's a mouthful. We could subtract 27 from both sides, and then divide both sides by 9. And I, be honest with you, I'm not great at subtraction, so 90 minus 27, I might make a mistake on that. Or I could decide right now, using the division property of equality, to divide each of these terms by the same number, since 9 goes into each of those evenly. If I chose that option, it makes my calculations easier, because 9x divided by 9 is x, 27 divided by 9 is 3, 90 divided by 9 is 10, and I get x is 7. Had you went the other route and subtracted 27 and divided by 9, you would still get 20. You would still get 7. That's the beauty of algebra. If you follow the rules, you can do lots and lots of different ways. The question asked, find the measure of angle dog. Once you know what x is, make sure you answer the question, which we haven't done. Measure of angle dog is 2x plus 18. We know x is 7. So that's 14 plus 18. That is 32, I believe. I believe. Don't want that. That was a horrifying mistake. There we go. Number 2. Angle HAM and angle CES are supplementary. Notice that these two angles have no letters in common. Since they have no letters in common, I need to draw them completely independent of each other. A is the middle letter, so it's the vertex. Angle CES, E is the middle letter, it's the vertex. I know they're supplementary. I know when I add their measures, I get 180. Measure of angle HAM is 4x plus 27. Measure of angle CES is 14x plus 9er. Find the value of x. Well, to make my equation, using letters, I can say the measure of angle HAM plus the measure of angle CES equals 180. I know that because it says they're supplementary. Measure of angle HAM is 4x plus 27. Measure of angle CES is 14x plus 9er. Starting to get sloppy with my handwriting, which means fatigue is setting in. Combining like terms, 4x and 14x is 18x. 27 and 9 is 36. I'm going to use the same strategy I used on the last problem. To make this simpler, for me, I'm going to divide each term by 18. You don't have to use this method. Since they all go into 18, 18 goes into all those evenly, I'm going to 18 divided by 18 is 1x, 36 divided by 18 is 2, 180 divided by 18 is 10. I get x is 8. Once you know what x is, read the question. Find the value of x. We have done so, so we are finished. Number 3. Angle sup and angle put form a linear pair. So a linear pair, I know, is a straight angle. It has a ray coming off of it. So what is what's the vertex? It's the center letter, U. What letter do they have in common? They have a P in common, so that's got to be on the common ray. And then S and the T are the letters they don't have in common, so on one of these rays I put an S, on one of them I put a T. There's my picture, a linear pair. Now I know, according to the supplement theorem on the previous page that a linear pair is always going to be supplementary, adds up to 180. Measure of angle sup is 2x minus 20. Measure of angle put is 3x plus 10. Find the value of x. According to the definition of supplementary, the measure of angle sup plus the measure of angle put equals 180. Sup is 2x minus 20. Might not be able to see that because my handwriting has gotten worse than normal. That's saying something. Plus the measure of angle put is 3x plus 10. Combine like terms. 2x and 3x is 5x. Minus 20 and a plus 10 is a minus 10. And for this one, dividing each term by 5, I think it's going to be easier for my brain to add 10 to both sides. And then 200 divided by 5 is 40. This is 10 less than that, so I'm going to say that's 38. Once you know what x is, answer the question, find the value of x. X is 38. Number 4. Find the measure of angle 1 and the measure of angle 2. Well, this angle and this angle are vertical angles. Since they're vertical angles, which angles I'm talking about here, the measure of angle ACB is going to equal the measure of angle DCE. So measure of angle ACB is 41. Measure of angle DCE, that's the measure of angle 2. So I know what the measure of angle 2 is. That's easy. And then using the supplement theorem, measure of angle 1 and the measure of angle 2 are supplementary because they form a linear pair. It's a line with a ray coming off of it. Since I know the measure of angle 2 is 41, I can subtract 41 from both sides and get the measure of angle 1 is 139. Answered the question, know what angle 1 and angle 2 are. They're measures. Last one, number 5. Excuse me. Find the value of x and the measure of angle cab. Well, check it out, chillins. These are vertical angles, so they're congruent. Vertical angle theorem says that the measure of angle phi is going to equal the measure of angle cab. Measure of angle phi is 2x, measure of angle cab is x plus 40. If I subtract x from both sides, I get x is 40. Find the value of x. Did it. Find the measure of angle cab. Haven't did it. That's x plus 40. So that's 40 plus 40, a little something I like to call 80. Did we answer both questions? You betcha. We are finished. Please do the homework according to the website.